welcome back to the channel. It has been a busy week about all this like classes and career fair, so I stopped uploading for a bit. But yeah, here we are again. So we're solving this problem, sentence similarity 3. So you're given two string in the way that they're sentence, and each of the word lists separated by a single space, with no leading or like following space in the end. So each word only consists of uppercase and lowercase English character. So the problem here is two sentences S1 and S2 are considered similar if we have this space to insert an arbitrary sentence inside one of the sentences that are shorter and make them to be equal. So let's say we have the example hello Jen, and S2 is hello, my name is Jen. So we can insert my name is in between them in S1. So this is true. But let's say for this one, right, you can't just create a S in the front and add an R right there. So this is not possible. Or in another case is what given here in example 2 is that, is that it's just given something like off, and you can insert a lot before off and words after off, but this is not a single sentence that we're inserting two sentences in two parts, so this is not right. For eating right now and eating, it is true because you can just insert right now into a sentence too, right? So intuitively you can think about, yeah, we need to do something to process this, right? Let's say this example, right? I want to have like something to take care of whatever start in the front if they're the same, or whatever start at the back they're the same, right? And then when this two hit, so one way I was doing in the beginning is two pointer, but it's actually harder to decode about it, which is when you can just have pointer pointing the start of here and the end of here, and then at some point when you hit the start and end are the same, you know that hey this two hit but then this two doesn't, it means that we can insert like an arbitrary sentence in between to this sentence to make it similar, right? But also there's another way of doing it, which is we're using a deck. So this is what I'm going to cover today. So we're using a deck, right? So we can make this sentence 1 and 2 to be a deck. So deck 1 will be like mine, and then name, and then is, and then Haley, right? And then deck 2 will be mine and Haley, right? So what we can do here is we can just go from the front first. For the deck, we compare if the first one is the same, we pop them out until we didn't hit anything that are the same anymore, right? So name and Haley is not the same. But then we can go on to the last part, which is the end part, right? So we go to the end part and then we compare. If they're the same, we pop them out, right? So this is what I said when I was saying two pointer, right? At the end of the day, this two will hit, right? The start less than end when this hit this one, and then we done processing one of them, right? So this is the same. At this point, this deck will actually be empty, right? Because we pop this mine out, and then we pop this Haley out, right? So as long as we know that one of the deck is gonna be empty, then we know that they can just insert arbitrary part in between, right? So let's say we have right, I'm not sure if this is kind of distracting. All right, so let's say we have eating and right now, right? Eating right now and eating, right? So when passing the deck, right? This is deck 1 and 2, right? So when passing the deck, we want to pop from the front, right? And it's done. This is gonna be empty, and then this is right now, right? So we're done. So when we try and pop from the right, it doesn't have anything the same. So we can just return if one of the deck is empty. So there are only three cases when I think about it. There's three cases that can be true. First case is where you have like the first what we said right here. You have front, the starting is the same, da da da, and then the end is the same. Or you have something that's like this, eating, and then the back has nothing, right? So it's just front, da 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 da, and then third case is da 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 da, and then end. But all these three different cases will just come down to be the same, that you can use two decks to solve this. Right, so let's just dive into the code and then can expand from here. So first we can just have deck 1 equals to deck, and then we can just split sentence 1. And then we can also have deck 2, and then we split sentence 2. Right. So what we say is that we can compare the first part first. So we can say, well, we still have the deck, and the first element of deck 1 is equals to the first element of deck 2. Then we pop. So let's know that actually the deck can be popping from the left and right, right? So when we said dot pop, it's like a stack that you just pop from the right. So if we want to pop from the left, we need to specify this to be a pop left. Right. So you can do the same thing here again while just comparing when they're the last element, right? We're done comparing the first one, so we're gonna compare the last one. And then we can just pop them. So what's something we want to return right here? What's a value or the true false? How we gonna return it, right? So we say that we can return if one of them is empty. So what is making it empty, right? So if this is making it, well, this is saying that this is not empty, right? So if we want to say something is empty, then we should say return not that, because it's not a deck anymore, it's actually empty, right? So you want either one to be empty, so you can just do this. Okay, run. So the runtime for this is actually let's run this first. Is of m plus n, because we need to go through the splitting part, we keep building the deck, and then we just want to go through the element of it. So yeah, let's see if we can do this. Of n is what is that, and then the space complexity is the deck that we created, so it's m plus n as well. Right, I hope this video is helpful, so we'll see you on the next video.